Hi everyone. Sorry I can't be there with you, but I feel like you're in good hands with what the task is for today. There's nothing new. As you see in this handout, there's really no new math techniques. All you need is SOHCAHTOA to be able to manipulate 90-degree triangles. Today's lesson is really just looking at different kinds of questions and getting more exposure so that you have more practice drawing your own diagrams, your triangles rather, and figuring it out. Okay, and so some of you still have to do the little outdoor excursion thing where we measure the flagpole outside with the class. Some of you will have to use class time to do that. It shouldn't take you more than 30 minutes, but you have all class time to do it. In fact, I encourage you to sort of put in some earplugs and work through that before, because this is a video and you can always go back to it at a separate time. As I said before, today's main goal is not SOHCAHTOA. If you need help with SOHCAHTOA, you have to go back to our 5.1 lesson. That is a full review of grade 10 material, so if you are having trouble with it, you need to go back to grade 10 material. Okay, go back to 5.1 and be able to do all the homework. Today's goal is looking at and reading questions, figuring out what they want, draw your own triangles, and solve. Okay, here we go. A surveyor stands at point S, that would be right at the bottom, and uses a laser transit and marking pole to sight two corners. You've probably seen this before. As you're walking around, there's like a tripod and people are like doing surveying the land. I'm not quite sure what the city uses it for, but they need data essentially to see if some kind of plan that they have is viable. So two corners, A and B, on one side of a rectangular lot. So this is my lot. The surveyor marks a reference point P on the line AB so that the line from P to S is perpendicular, so it's 90 degrees to AB. Corner A is 150 meters away with an angle of 34 degrees. Corner B is 347 meters away from S at 69 degrees. You don't see the question, sorry, but the question is essentially, how long is the lot size? Okay, I must have cut that out. That's my bad. So what we're trying to do is, excuse me, again, you don't need anything other than SOHCAHTOA. If we are looking for the length of this lot, you may have noticed that that is actually the sum of the bases of these two triangles. Oops. Okay. So that's what we're going to do. I'm going to zoom in so that you can see the numbers better. We have a triangle. I need, let's call this side little x, and we'll call this side little y. Okay, if I wanted to find little x, it happens to be the opposite side of 69 degrees. This happens to be the hypotenuse of this triangle, and so opposite side, hypotenuse, all we need is sine. Sine of the angle is equal to opposite over hypotenuse. With this, you should be able to find x. Next, the same results are, the same ratio is seen here. Opposite side is the y, the hypotenuse is 150. Sine of 34 degrees is equal to opposite over hypotenuse. And so I should be able to find x by multiplying both sides by 347. And that would equal, let's see, make sure my calculator is in degrees, 347 times sine 69. This is approximately 323.95. My recommendation try rounding it to 2 decimal places for the moment. Okay. This distance is 323.95. It might seem like a big number, but is it realistic? Well, it's at least smaller than the hypotenuse, and you know the hypotenuse is always the largest side of a right angle triangle. Next, multiplying both sides by 150. 150 sine 34 is equal to y. Therefore, y is approximately times 34, 83.88 meters. Okay. So adding those together, 83.88 plus 323.95. So I would say, therefore, the length of the lot is 407.83 meters long. There it is. I don't expect this to be particularly challenging, but it was a good example to show you how 2 triangles with using SOHCAHTOA will help you with a larger problem. Next question is going to involve you drawing your own triangles, and it is in fact a lot more challenging. It also includes words like angle of elevation and angle of depression, words that you have run into before in grade 10, and a word that you have encountered when we did the flagpole, activity yesterday. Let's take a look. Karen is a photographer taking pictures of a skyway, a bridge. She is on a helicopter hovering 720 meters above the bridge, and when we talk about height, it's perpendicular to the ground, okay? Exactly 1 kilometer horizontally from the west end of the bridge. The skyway spans a distance of 2650 meters from east to west. From Karen's position, what are the angles of depression to the nearest degree? Okay, there's a lot to do. How about we take this information and see if we can draw an accurate picture? Starting off, I have with me a helicopter. It's the best helicopter I can give you right now. Okay, it's not bad actually. Nice. And it is directly above a skyway 720 meters above. So that's actually quite high. And let's pretend this is my bridge. The sky exactly 1 kilometer horizontally from the west end of the bridge. So let's pretend this is the west end. And the distance from here to the helicopter horizontally is 1 kilometer, otherwise known as 1,000 meters. The skyway spans a distance of 2650. So from all the way to the other side, that is 2650 meters. And I feel like this is necessary. If this is 1,000, what is the remaining part of the bridge? 1,650 meters. Okay, so let's continue. From Karen's position, which is, I'm going to call this K right here, what are the angles of depression to the nearest degree of the east and west ends of the bridge? So I am trying to figure out an angle from here to there and figure out an angle from here to there. How about I use line tool to actually create that? But here's the problem. Please don't get this twisted. Which angle is the angle of depression? If you remember, if this is my person and this is my eyeball, looks more like a bird, the angle of elevation and the angle of depression is the angle you make with the horizontal, always. So in other words, if I am looking down, I am depressing, I am lowering my eyesight. So the angle that I create with my eyesight and the horizontal line is my angle of depression. An angle of elevation is when I elevate my eyesight, and from the horizontal to my eyesight, would be my angle of elevation. So in the helicopter, when I say angle of depression, I am not talking about this angle. I am talking about this angle. And the only way you can figure that out is if we figure out the angle within the triangle. Because the angle within the triangle, this interior angle, and the angle of depression have a relationship of 90 degrees. Okay? What are the angles of depression to both sides? So how about I start with this triangle? I have with me a height of 720. I have with me an opposite side of 1,650. I can use these two sides, the opposite and the adjacent, to find my theta, to find my alpha. So tangent, I'm gonna make my pen stroke a little thicker because it's nicer to see. Tangent of alpha is going to be opposite over adjacent. And if I want to get rid of the tangent and leave the angle all alone, I will have to do the inverse of my ratio, of my function, to both sides. At a certain point, I'm going to stop writing the inverse on both sides because as a mathematician, I am a little lazy. But I need you to know that it's not some arrow bringing from left to right like you might do for addition or subtraction. It's actually doing the inverse, just like your algebra. Okay, I've been stressing this in class. So inverse tangent of 1650 divided by 720. Please see if you get this. If you do this properly, the angle of alpha is 66.4 degrees. And because the angle of depression has a relationship of 90, angle theta will be 90 degrees minus the alpha, which means 90 degrees minus 66.4. It will be 23.6 degrees. The angle of depression is 23.6 degrees. I'm going to repeat this calculation for, let's call this beta. And let's call this part beta, and this part will be gamma, like the letter G. Divide. And I have a height of 720, that's the adjacent side. The opposite side is 1,000. It's the same ratio. Tangent of beta is going to be opposite over adjacent. And so angle B is going to be the inverse of 1,000 over 720. Inverse tangent of that is going to be approximately 54.2 degrees. Therefore, the angle of depression would be 90 minus beta, which is 35.8 degrees. Okay. There it is. And that will be the end. The angle of depression will be 23.6 degrees, and the angle of depression will be 35.8. If you gave me 66.8 here and 54.2 here and said those were the angles of depression, I cannot give you full marks because you did not address the question. Okay? Let's quickly do part B. If Karen's camera has a wide-angle lens that can capture 150 degrees, can she get the whole bridge in one shot? Well, we just said angle alpha is 66.4 degrees, and we just said the angle beta is 54.2 degrees. Will she be able to take her camera and capture all of the bridge using 150 degrees? The answer is yeah. So let's show that. I'm going to add 66.4 plus 54.2, which is 120.6 degrees. that is smaller than 150. So I would say yes. Capturing the entire bridge will span an angle of 120.6 degrees only. Oops, does this not work? Darn, it does not work. Angle of there it is. Okay, there we go. Example 3 is a little bit deeper because after you calculate this, you have to do a little bit of money conversions. And I hope everyone's interested in enough to know that final stretch. It's something you sort of need if you want to apply this to more meaningful things in real life. Okay? Elise's parents have a house with a triangular front lawn as shown. What a weird front lawn. They want to cover the lawn with sod rather than planting grass seeds. How much would it cost to put sod if it costs this much per square meter? What? Yeah, what we're trying to do here is calculate the area. Why? Because if we know the area, we know how much space needs to be covered. And if we know how much space needs to be covered, we know how much it'll cost per square meter to cover. And so we get our our cost is going to be the area we need to cover multiplied by 13.75 per meter squared. You know the area is going to be meters squared, so the leftover is going to be in dollars. That's our goal. So what's the area? If you recall, the area of a triangle is half times the base times the height. Base, I already have. My question is, what's the height? The height is not the third side. The height is always going to be a distance perpendicular with the base. And that's actually helpful. I want to give you half a minute to think about it. So if the substitute wants to pause the video, they can. Have you thought about it? If you want the height of this triangle, you essentially can take a scissor and cut so that you have a perfect 90-degree triangle. Like this part is gone. Why? So that we can use SOHCAHTOA. Right? This is still 40 degrees. This is still 13 meters. This is no longer 11, but I don't need it because I am looking for the height here. Let's call this A. Let's call this H. I'm looking for that height. So, how do I find the height? If using this new triangle that I created with this part cut off, the height is the opposite side. The 13 is the hypotenuse. Opposite and hypotenuse. That would be the sine ratio. By using sine 40, I have my height over 13. What's next? I need height all alone. I'm going to multiply both sides by 13. So my height is going to be 13 meters times sine 40. That is approximately 8.36 meters. Let's use it. I need area. Let's do this. And thicker arrow. Okay. My total area is going to be half times my base. What's my base? 11 times my height. What's my height? 8.36. Base times height, which is equal to 11 times 8. That would be 18.392 approximately meters squared. Super important. That's going to be poor form if you don't do it. Okay, 18.392. Going back to my original, I want to know how much it costs, and so my cost is going to be $13.75 multiplied by 75 cents per meter squared multiplied by 18.392 meters squared leaves me $252.89. Okay, important. So even if you think about it this way, in this question, the question presents itself as you are the one who wants to do it yourself and how much it will cost you. What if you were the service providing this service to others? You might want to know how much it would cost you to create to give you an idea of how much you would charge others to pay you, right? And a good business model, in my opinion, would be at least charge double your cost so that whatever you spend, you earn back as well, minimum. So something like this kind of service, if you were to be hired to cover this, maybe you would charge like $400 or $500 for the entire thing. And even if it's $500, half of that would be gone from cost. It's not going to your pocket. It has to cover material cost, right? So these are very simple, linear, maybe even unrealistic examples of how math and trigonometry can be directly applied to situations in life and situations that you might be concerned about, such as money. Please try these homework questions. Please do not leave it till last minute. Expose yourself to as many word problems as possible, because come next week, we are just looking at more and more word questions. Trigonometry chapter 5 is all about word problems. So please, practice it. Hope you have a good weekend though, and do not leave this last minute. You will regret it. Okay? Have a good one. We'll see you when we get back.